This is R.D. Sharma solution, class 12th, chapter 11. Differentiation exercise is 11.1. Differentiate the following functions from first principles log cos x. Now the first principle we already know. It is fx plus h. If this function is fx, then fx plus h, wherever x is there, we'll put x plus h, minus fx divided by h, limit h tends to 0. So this what we do in first principle. So those who want to do themselves, I have given a reference, and those who want to understand, just see the logic. How do we go about it? We have log cos x plus h, because if x plus h we have to do, minus fx, that is log cos x, divided by h, and limit h tends to 0. So these two we are going to use wherever it is required. Let us see the numerator first. And in log, we know the property log a minus log b is nothing but log a divided by b. You can also call it as log x minus log y is equal to log x by y. So let us write it as log cos x plus h divided by cos x. So are we going to get something out of it? Not yet. But we have certain relationships, certain identities that we have been using, and that will be used all through your differentiation and integration. Log 1 plus x divided by x, limit x tends to 0, is equal to 1. And we have e to the power x minus 1 by x, limit x tends to 0 equals 1. So this need to be kept into your mind. But we don't have any 1 plus here. So we will by ourselves add a 1, subtract a 1 in order to get this kind of identity. So 1, just keep it aside like this, log 1. And the other part, which is cos x plus h by cos x minus 1. Let us solve it in a different place. So this is cos x plus h minus cos x divided by cos x, that is cos x plus h by cos x minus 1 is cos x plus h minus cos x divided by cos x it will be. Alright. So now this whole you can keep it here. Now writing this will take some time. So I just use a symbol y in place of all this content. So log 1 plus y. But still you need a x in the denominator, that is whatever is y, you need a y in the denominator. So if you are including or introducing a y in the denominator, you also have to have a y in the numerator, because you are introducing by yourself. Now log 1 plus y by y, when y tends to 0, you don't have to do like this. You have to write everything by yourself, okay? You cannot just regard something like this. We will be doing it in a later question. But here, because this is not that big or that time consuming, so log 1 plus y by y is the whole term which on the right I have written. But log 1 plus y by y, log of this is going to be 1, which I already told you. So all of it, all this part, you can just call it as 1. So this whole which I am making making a boundary, the inside content will be 1. Now only y will be remaining. Y is what I regarded or used the symbol y for this whole content. So let us write it and try to solve it. So we have cos a minus cos b. Cos a minus cos b is minus 2 sine a plus b by 2 sine a minus b by 2. Let me write it here. Cos a minus cos b is minus 2 sine a plus b by 2 sine a minus b by 2. So this you can use. A is x plus h and b is x here. 2 sine 2x plus h by 2, and then we have sine x plus h minus x by 2. X gets cancelled, you have h by 2. Remember, h was already there in the denominator. So I'll use it here. Let us write this h in the denominator. But still, you know that sine theta by theta. So you need a theta in the denominator. So h by 2 has to be there. So 2 multiplied by h by 2. Now apply the limit in this circled area. It will be 1. Sine theta by theta, limit theta tends to 0 equals 1. 2 gets cancelled. You have minus 2 sine 2x plus h by 2. You can again apply the limit because you will not get any indescribable value. So minus 2 sine, this h is 0, 2 gets cancelled. So you have limit h tends to 0, 2x, this is 2 gets cancelled, you have x here. Alright, this is your sine x. So you have a sine x here, and if you remember, we have a cos x in the denominator also. This cos x was in the denominator. So right now, this is the time to have this cos x in the denominator. Minus sin x by cos x. Sin x by cos x is tan x. So this is tan x. Final answer, final solution of log cos x differentiation is negative tan x. Alright. So, I just wanted to show you how to do this. That's why I skipped something. Next is e root cot x. We have to solve it using the first principle. So those who want to themselves try this question, and they have a reference on the left I have given. But those who want to understand how this has to be done, we will be using certain identities. E raise x minus 1 by x limit x tends to 0 is equal to 1. This is the first thing. We will try to make this e under root cot x like this. The second relationship we are going to use is cot a minus b is equal to cot a minus cot b plus 1 divided by cot b minus a. Please remember, the b is first, a is later. Then we will use 10x by x or x by 10x. Both ways, when you take limit x tends to 0, we'll take limit h tends to 0, and this is equal to 1. There are certain other thing like cosec square theta is equal to 1 plus cot square theta. That also we are going to use. This I told you upfront because we will be applying it in the course of solving this question or differentiating using the first principle. Fx plus h minus fx by h, limit h tends to 0. That is how we go forward for the first principle. This is our fx. E raised to under root cot x is our first principle. Alright. So e root cot x plus h, that is fx plus h, minus e root cot x, this is fx, divided by h, limit h tends to 0. So whenever we have this h and limit h tends to 0, I am going to apply it, use it. But right now we are concentrating on the numerator. Numerator is very important. This, because we are not able to find any way out, the best way out is to take the e root cot x common. When we take e root cot x common, it was not there in the first term, so you have to divide that term so that when you multiply it gets cancelled out. So e root cot x plus h divided by e under root cot x minus, we already taken e that content outside, so you can have just minus 1. So what I am trying to suggest here is e under root cot x is the first term which is already we got. So I am just making it a circle around it in order for you to later know that we have this term already. There is one more relationship. X to the power a by x to the power b is x to the power a into x to the power minus b, and then you can add them, so it will be x to the power a minus b. This is same thing we are going to use because base can be same, the power gets subtracted when you have in the ratio. E raise under root cot x plus h minus under root cot x, this is what you get here, minus 1 divided by e under root cot x. But see, e under root cot x is also there. So we need this term. We need this term under root cot x plus h minus under root cot x. So this term we require it. Okay. So what we will do here is this under root cot x plus h minus under root cot x that we have introduced. Okay. So this limit h tends to 0, and this whole term because e to the power x minus 1 by x is going to be 1. Remember, this was already there. We are going to use it in a short while. This term under root cot x plus h, this we are going to rationalize. So we have this term remaining cot x plus h minus under root cot x. In order to rationalize, just multiply the same term with a positive sign. The same term with a positive sign, multiply here, under root cot x plus h. Then we have this under root cot x, same thing in the denominator. Under root cot x plus h plus under root cot x. So now we have a minus b, a plus b kind of situation in the numerator. This is a minus b, this is a plus b. A minus b and a plus b is a squared minus b squared. Since we have this in root, so you can get this value without the root, that is, root will be eliminated. So cot x plus h minus cot x divided by this term. Since this term is not giving us any untoward value, you can apply the limit h tends to 0 here only. So in the denominator I am applying limit h tends to 0. It is going to be under root cot x plus h, h will be 0. So you have under root cot x plus under root cot x, that is twice of under root cot x. So twice of under root cot x we got. Now I am again circling it because this is the second term which we will be having in our answer. So what is remaining? E under root, this thing, let me write it here. E root under root cot x, twice of under root cot x is already there. Now we have to deal with this one, cot x plus h minus cot x. Now what is cot a minus b? Cot a into cot b plus 1 divided by cot b minus cot a. So if I just change the term, okay, replace the term, we have to, if I want to get a cot x minus cot x plus h, I have to multiply it by a negative. So when we multiply it by negative, it will be equal to the first term. So minus I will be using it. So I am just keeping this negative here. Cot x minus cot x plus h. So we will apply this formula. Cot b minus cot a will be equal to cot a cot b plus 1 divided by cot a minus b. So it will be cot x plus h minus x in the denominator. So we have cot a cot b cot x plus h plus 1 divided by cot x plus h minus x. X plus h minus x is what? X gets cancelled. You get a cot h. You have a cot h here. So now, see, you can apply again the limit here. So you get this h. Cot h is tan h. I told you tan x by x or x by tan x, limit x tends to 0, it is going to be 1. So this is going to be 1. So this whole term in the denominator is 1. So the term in the numerator is cot x into cot x plus h plus 1. Apply the limit here. Cot x, this is going to be 0. Cot x into cot x is cot square x plus 1. So cot square x plus 1, you know that cosec square theta it is. So cosec square x. Now this is what we got finally. Already we had this term. So I am just taking this cosec square x here, and that will be our final value. That is going to be final answer differentiation of this term.